Hello my friends, and welcome to this new step of this implementation where we're going to use the elbow method. Well, actually we're going to implement the elbow method to find the optimal number of clusters. I remind that before identifying the patterns with the k-means algorithm, well, we have to find first the optimal number of clusters, and that's what we'll do in this step. And to do so, we are going to make a for loop that will plot the WCSS. Remember, this is the within cluster sum of squares. That is the sum of square distances between each point and the centroid in a cluster for 10 numbers of clusters. Alright, so we're basically going to plot the WCSS within cluster sum of squares for the different numbers of clusters going from 1 to 10. Okay? And this will plot an elbow, and our optimal number of clusters will be exactly the number of clusters where we have the elbow itself. Alright, so let's do this. Are you ready to actually make your first for loop of this course? It's going to be some pretty good code practice. Let's also get our hands dirty. Let's not only use libraries. So here we go. Let's create a new code cell. Alright, so before we're going to plot something, the first thing we're going to do is import the PyPlot module by the matplotlib library. The PyPlot module is an excellent module that allows to plot some nice graphs in Python. Alright, so that's our first step here. Let's import the matplotlib library from which we access the PyPlot module. Alright, well, I pressed enter too fast. It already found the right shortcut name for this. Indeed, we usually call PyPlot PLT so that we can call it easier. Okay? Then, what is the next step? Well, the next step is to import another tool that we're going to need to implement this elbow method, which is the k-means class. And so, we're going to start from scikit-learn, because this k-means class belongs to the cluster module by scikit-learn. So there we go. From the scikit-learn library, we're going to access the cluster module. There we go, cluster. And so, from this cluster module by the scikit-learn library, we're going to import the k-means class. So here, be careful, it's capital K and capital M, which is exactly a class that contains the blueprint of how to implement the k-means model. And of course, each instance of this k-means class will be the k-means model itself. Alright, but since when you create an instance of this k-means class, you have to specify already the number of clusters you want to perform k-means with, well, we must not create our instance now, but within the for loop. Alright, so you will see that we will create the k-means model object later for each of the numbers of clusters that will be on the plot. Alright, but before we start the for loop, we have to create a new variable which will be the list of within cluster sum of squares for each of the numbers of clusters. And so, since it is a list, well, we have to initialize it with an empty list. And the way to do this is first, well, create this variable that will be the list itself, and we can call this WCSS, and then just initialize it as a pair of square brackets, right? Lists in Python are basically elements within a pair of square brackets, if it's a simple list, okay? And that's what we need before starting the loop. And so now, well, we're ready to start the loop. And to do so, since it's going to be a for loop, we start with for. Then we give the loop index, which we're going to call I. And then we're going to specify the range of values that is going to take this loop index. And since we want to plot the elbow method for the numbers of clusters going from 1 to 10, well, here we'll choose our range to go from 1 to 10. Alright, and the way to do this in Python is just to add in range, and then in parentheses, you give first the lower bound of the range that is included, but then remember, be careful, we give the upper bound of the range, which is excluded, right? It's the same as when we selected our columns in our array of independent variables x in the two previous implementations. So here it's the same in a Python range, well, the upper bound is excluded. And since we want to plot our WCSS for the numbers of clusters going from 1 to 10, then here our upper bound should be 11, because 11 will be excluded, and so it will go up to 10. Alright? And then we don't forget to add a colon here to start the loop. Great. Now now is the time to create our instance of the k-means class. Because from this instance, which is our k-means model itself, we will be able to call some methods, and the one that we'll need is the fit method. Because just like for linear regression and logistic regression, the fit method will train your k-means algorithms for each of the numbers of clusters going from 1 to 10, and then we will use an attribute of the k-means class, from our object, which will give us exactly the within cluster sum of squares. And the name of that attribute is called inertia with an underscore. So let's do this. This will be more clear once we implement this. So first, we create the instance of our k-means class, which we're going to call very simply k-means. All right, and then you know how to create an instance. You simply need to call the class itself, which is k, capital K, then capital M means, k-means. Then you add some parentheses, and here we will enter 3 arguments. The first one is the number of clusters, as you can see here, which is a compulsory one. And so this will train the k-means algorithm on your dataset with the number of clusters that you specify. And so here, since we are dealing with a particular number of clusters within the loop, well, the number of clusters is exactly I, at the step of this loop. And so we're going to enter here our first parameter, n underscore clusters, equals I, right? Our loop variable. Then, second argument, we should specify the initialization method. And as you saw in the intuition lectures, a good and optimized one is k-means plus plus. So actually, let's copy this because this is exactly what we want, right? Init equals k-means plus plus. And then one less argument just for the purpose of this training. If you want to end up with the same result as me, let's put a seed with the same value for all of us so that we can end up with the same results. Only if you want to, then you add this random underscore state parameter, and which we're going to set equal to, well, let's change for once. Let's choose the value 42. Great, so now let's take a small break and we'll do the rest of the elbow method in the next tutorial.